And welcome everyone. My name is Alex Gorelik, and I've been working on data classification for many years at companies like LinkedIn, Meta, IBM, Informatica, and lots of startups. It's a very interesting topic, and let's get into it. So today we're specifically going to talk about data classification for data privacy. And data privacy is a large space. We're not going to cover all of it. But if you think about the ecosystem, right, on the left you have government regulations, user commitments and expectations, industry policies, internal policies, and so on. And on the right you have all kinds of technologies, right, policy enforcement, right, policy, privacy enhancing technologies, reviews, reporting, and so on. In the middle you have processing activities and data. And that's how GDPR, for example, describes the world. And the problem is, if you don't know the data, you can't govern it, right? You can't really govern what you don't understand. So most of the government regulations really focus on what I'm calling data mindfulness, right? Know what data you're processing for which purposes in which processing activities. And if you look at ROPA reports, most of the regulations are focused on that. Like, let people know how you use the data and use it according to how you are supposed to use it. So what's data classification, right? Think of giving semantic labels to data, right? For you to enforce policies, you really need to know, what does this data mean? And since we're again focused on policies, let's look at some sample policies. So these are kind of made up LinkedIn examples, but if you're a member, you can have self-identify disability status. And the top line says, okay, well, you can't use disability status for ads targeting. The second line says, if you're doing bias detection, because companies want to know if they're biased, then you can use disability status. And then the third line basically says, if you go to your LinkedIn profile, you have this little pop-up that says, what job information can we use for relevant ads? And you can say none, or you can say current job, or you can say past jobs. So what the third line says is, yeah, you can use for ads targeting, but only with consent. So these are very simple policies. They get very complex, but I think enough to give us an idea of what we need to annotate. The labels, annotations are organized, right? Because some people just have a flat list, but usually that doesn't scale very well. Most companies end up with taxonomies or even ontologies because they want to do policy at a higher level, right? They want to be able to say all sensitive data rather than list in each policy every possible label that could be sensitive. Then we look at, there are two things, right? Granularity, like what level do you label things at? The most common one is field, right? Like this field contains disability status. But sometimes you do it at dataset level, right? Like this dataset contains job information, and sometimes you have to do it at record level. Like if we look at current job rule, if I say you can only use my current job, typically it's neither a field nor a dataset. It's some flag that tells me this job is current. So then I have to go to record level and figure out how to express that for my policies. So then there are two aspects of that, right? How do you express it and how do you automate it? So let's look at those. Expressibility, field level, very straightforward, right? You label a field with disability status, and now you can apply policies that say, oh yeah, if you're doing ads targeting, then instead of the values in this field, we're going to return null. Or if you're doing bias detection, then we're actually going to return this field as is without redacting it. Unfortunately, there are a lot of complications, right? One is multi-label fields, right? Frequently, fields contain multiple types of data. Very classic example, people like to have contact type and contact info, right? Contact type could be email, phone number, address, and so on, and contact info will be the actual email or phone number. What do you label it? Do you give it multiple labels? What if you have conflicting policies? One says you can have email but not phone number. How do you enforce it? So that's a complication. Very common to have different enumerations. You can have 2-letter country code, 3-letter country code. Gender could be male, female, non-binary. It could be 1, 2, 3. Do you label it with the same labels? Do you label it with different labels? How do you communicate to your policy what this is and how to use it? Then you have derived fields, right? So, okay, we have disability status, but maybe we have a demographic flag that's partially based on disability status. Now you have to apply the same policies. You have to figure out, how all the same policies apply, different policies apply, and so on. Even more tricky, you have filters, right? What if you have a data set of users that are all disabled, but there's no disability flag in the data set? Well, you should treat it as if it's disabled data, but how do you know? You have to communicate somehow to your policies that it's for disabled people. Aggregation is the same thing. If you aggregate and have, let's say, number of disabled people per company, is that okay? Do you apply the same policies? Do you not allow to use it for ads targeting? Or, and then obfuscation, right? The privacy enhancing technologies often introduce noise into the system, obfuscate data, or somehow synthesize it. Do you treat it the same way, right? Do you label it the same way? So lots of complications. I'm not gonna describe how to fix all of them, but I just want you to understand that real life is really messy, and nice, elegant technologies usually don't completely work, and you have to enhance them, or keep building more and more pattern detectors. Then you have dataset level expressibility, right? How do you label a whole dataset? Bottom up based on what fields it has, top down where you just label it. Lots of approaches here. And the record level, which is the trickiest one, is we talked about current jobs, right? How do you express, how to determine which job is current? Maybe it's end date field is null. That means it's a current job. Maybe it's a flag. Maybe it's something else that tells you what job is current. And then consent, right? We talked about this is only allowed if the user consented. Well, that's a record level decision, right? Because a specific member, some members consented, some not. And usually you have to then join with some consent table, do a lookup. But again, it's a record level decision that can only be done at runtime on each record. Now, let's talk about manual annotation. Most companies do things manually, and the big problem is it's not sustainable by itself, because every time you add a new label, you have to review every data set. Unless you labeled every single field with all the existing labels, so you fully label everything perfectly, then new labels can only apply to brand new fields that you derived. Reality, obviously, nobody has that, so usually people just label the core set of fields, and when the new label comes up, core set of labels, when the new label comes up, they have to go relabel the whole world. Then the question is, when do you label? So you do it either when data set is created, because you know all the fields. You just created, you actually understand why you created it. Or sometimes people do it after they do some automation and then provide that information for labeling. And the really interesting question is, what do you do with fields that don't have labels in the ontology? Or in general, how do you grow your ontology, right? Like, who decides it's okay to add this label? Top down, usually it's done based on policies. Okay, we have a new policy. This policy requires us to identify a new type of data, so therefore we have a new label. But if you're doing it bottom up through crowdsourcing and manual labeling, do you let people just give new labels that don't exist? And I've seen some companies adopt Wikipedia-style crowdsourcing, where data users suggest, dataset users and owners, and then taxonomists approve this, just like in Wikipedia, right? You suggest an article, and then nobody sees it until it's approved. The other technique I've seen that works really well is create different ontologies for different teams and have a central one that's managed, but different teams have full control over their own. And the main reason for it is because different teams call same things with different names and different things with the same name. And retraining everybody is very difficult. So it's much easier to basically have multiple taxonomies and have synonyms. So, but if we look at automation, and this is really for privacy, we have 6 levels, right? One is manual labeling we just discussed. And based on the whole number of places I talked to, it seems to be in the 75% precision recall. So for those not familiar with recall and precision, recall says, how many did you miss? So high recall means very few false negatives. And precision means how many did you mislabel? So high precision means very few false positives. And generally, manual labeling ends up in the 70% range of accuracy. You can enhance it by doing validation. And validation helps because like age looks like 1, 2, 3, 4, 5, any field in the range of 1 and 100 might potentially be age. But so it's very hard to maybe discover, but on the other hand, if you label field age, or if it's named age, and you look at the range and the range is not in 1 to 100, it's not age. So it improves your precision, gets rid of false positives. It doesn't really do anything for false negatives. And then there are lots of techniques for low precision recall automation. So for example, looking at field names. Well, if it's called age, it must be age, let's label it. And those are improvement over just purely manual labeling. But the problem is you still have to manually review each data set. If you can't guarantee that you found all the instances or enough instances, you really didn't move the needle enough. And unfortunately, this applies to all the labels that you need to write policies on. So for example, for discoverability, for data engineers and scientists to find data, it's actually pretty good. It doesn't really matter, right? It helps a lot. But for privacy, right, you need precision and some guarantees. So you really want to be in the upper right quadrant where you have high recall automation. Because if you have false positives, people will complain or change it, manually adjust it. So you're really reducing your manual scope to just data sets where there are labels for traditionally low precision. But if you miss something, you wouldn't know unless you look at all the data sets. And then ideally, you want to be in high precision recall automation over 90%, because at that point, humans actually don't move the needle that much. And that's pretty good. Obviously, you want to be perfect, but perfect is really usually not attainable. So if you can get into high precision recall, that's really the goal. Otherwise, you end up with a lot of manual work anyway. As far as automation, there are really 2 types of fields, right? One is recognizable. So fields with well-defined format, like phone numbers, driver's license numbers. And then fields with value sets, like religion, right? Or English first name. Like when you see a field as a human, you would know what it is. And then, unfortunately, most of the fields are not recognizable. They're Booleans, they're small enums and codes, they're dates, numbers, small numeric adds. Like we saw an example of disability code, right? Yes, no, okay. There are tons of Boolean fields. So how would a human do it? And I've done consulting where I actually had to do it myself. So what you would do is you would find a reference table that's well labeled, where they actually show you what data looks like. Then you take a target table and you eyeball it and say, oh, there are some recognizable fields. I can tell that N is name and PH is phone number because the format makes sense. But C1, C2, God knows what it is. So next step you would do is, oh yeah, and so there are different techniques to discover recognizable fields, sorry. One is static classifiers, right? Regular expressions work really well. Value matches using Bloom filters, so value sets work really well. if you have field level lineage, that's ideal, right? That can help you with pretty much any kind of data. But you often still have some ambiguity. Is 9-digit number social security number, some other ID? Is New York, if you just have New York, is it state or city? You don't know. So the best technique I found for trainable class, field level automation approaches for recognizable fields is trainable classifiers. And it roughly works as follows. You basically have a reference field that says, okay, here's what religion looks like, or here's what phone number looks like, or whatever account number in this company. You profile it. Profiling is a technique where you go for all the data and you just figure out its type, format, range, length, and so on. And then for each target field, you also do profiling, and then you calculate distance between the two profiles and names. So you do name distance and you do profile distance. Do the formats match? Do values overlap? Does the value length in the same range, and so on? And you give a weight to each of these features. And then as people curate, so you train this classifier, right? So you show it to end users and they say, yes, you got this right. No, you didn't get this right? And the way it gets adjusted and your classifiers get trained for each type of reference field to distinguish it from others. So it works really well and works at scale, but again, it's limited to fairly recognizable fields. What about non-recognizable fields? So what you would do as a human is you would find the same record or the same user, the same customer in both tables. Say, okay, well, same phone number, same name, must be the same. And I can see that C2 matches D code. But what about C1? Don't know. So then you would look at more and align all of them, let's say, on phone number. And you can see that, okay, C2 really matches decode. So it's probably decode, or very likely, because over millions of rows, it's not an accident. C1 doesn't match anything, but there's a pattern, right? Whenever gender is F, C1 is 0, and whenever gender is M, C1 is 2, which means there is alignment, right? Like this is the example of different enumerations that we talked about. So by doing this alignment, you can actually discover patterns that match across. So for non-recognizable fields, there are two main approaches that I found. One is field level lineage. If you don't have field level lineage, sometimes you can use dataset lineage. You can say, look, if parent dataset has gender, let's assume all target datasets have gender, even if we don't know if it actually used gender to generate that dataset. We don't have field level lineage. It's more restrictive, but more restrictive in privacy is usually okay because you put a more restrictive policy, people complain and manually fix whatever the problem is. Another approach is fault disco. This is a prototype I developed it at Meta and we open sourced it, and we did POCs both at Meta and LinkedIn, and it's showing very high precision recall, and can also be used to discover field level lineage. So here's an example of results, and you can see, by the way, the GitHub address of this project. So the basic premise of fault disco is reference and target fields align if target field is equal to some deterministic function of reference field. The function could be identity, could be anything, as long as it's deterministic, which means the same value of the reference field generates the same value of the target field. And in this example, you see it found all the fields they actually named the same and found its exact match, and the alignment strength is 1. It also found for some fields, even though they were renamed, it still found them and they matched perfectly, and it was able to find it. And for a couple of fields, it was able to find alignment. It found that this restriction type aligns with 2 fields on the target, is restricted and is login restricted. And you can see here the actual values that align. So it turns out that whenever restriction type is either set login restriction or set spam restriction, the is restricted is true. And you can express it as a case statement, right? And it basically shows you how many times it's true and how many times it's not true. And the case statement basically would say, when restriction type is in this set, then it's true. And then the second alignment is login restricted. It's only true when restriction type is set login restriction. So Feld was able to discover it and differentiate the two and actually provide the mapping. So it was able to find, let's go back, all the fields, including dates. There are 3 different dates, including small enums and years and so on, differentiate them correctly, map them correctly, as well as find places where it's actually not exact match, it's actually enum versus a Boolean, and correctly map them as well. So it's very promising. We're investing a lot into productizing it, but I have a lot of hope that will help, especially for privacy, to find all the critical data. It does have limitations, right? It needs alignment key. It needs to align on some key. We used phone number in the example, but we use member ID at LinkedIn, but you do need to be able to discover that alignment key first. So you need separate classifiers to find it. It also requires a set of comprehensive reference tables, right? If you don't have a reference for data, it won't be able to label that data. So typically you need additional classification tools and techniques. For example, in our pilot, we found that there are 2 email fields in the reference and target, they didn't match. And with the regex, we would have been able to identify it as email. We have no idea why it didn't match. It wasn't generated from the same data set, but it just didn't match. And then later we found out it's, business email versus personal email. Okay, dataset automation. Again, you can automate this, right? Especially if you do it bottom up by looking at the field labels, you can aggregate up and label data sets. And top down, again, dataset lineage is a great way of propagating all kinds of policy-related annotations. You do need propagation algebra when you have datasets with multiple parents, and it could be more restrictive than necessary. So in conclusion, it's a very complex and gnarly problem. Lots of different patterns. The reason I included the slide with all the complications is for you to get an idea of how messy the real world is. It really must be, for privacy specifically, must be automated using high recall automation techniques, because if you can't guarantee that you found the instance some critical fields, you have to manually inspect the data sets. And there are lots of different approaches. Most likely, you're going to need a combination of tools and techniques. There's no silver bullet, but if it's done right, enables lots of use cases, from privacy, data discoverability, reuse, rationalization, and so on. So with that, I think we have some time for questions. I was going to mention, if anyone is interested, I do have a book out on big data lakes and enterprise big data lakes. It touches on some of this material. It doesn't have Feld because it's a few years old, but it's on Amazon. You can just look for my name.
All right, so it looks like we have one question. Are there tools available for small startups to get going on this?
So if you're looking at your own data, small startups usually don't have a lot of data, and they kind of craft it, but generally regular expressions and good naming conventions work. If it's for your customers, then there are quite a few vendors providing technology in this space that you can partner with, like Hitachi. Vantara is one that actually bought my previous company, that they have a really good trained classifier implementation. And Feldiska is an open source prototype. It's a prototype, so doesn't quite work at scale or perfectly well. We already fixed a bunch of stuff, but it will probably get you a long way towards classifying key fields.
All right, another question. Will you be able to classify based on privacy risk or re-identification risk?
So, okay, so let's put them aside. So privacy risk, so classification is, this is what the data is, right? Privacy risk is usually assigned by privacy policies. So privacy policy will say, oh, if you have this type of data, therefore, um, you should apply these protections. You should encrypt it, or you should obfuscate, and so on. So, so it's we need to separate the job classification from that. And then re-identification, it's very similar, right? Like if you discover that a set of fields can re-identify, a user, then you look using, so you label fields using classification, and then you look for data sets where there is a combination of those fields, or data sets that are joinable that have a combination of those fields. So again, classification is more about what is. And then the reason you do it is so you can apply policies like re-identification, detection, and so on. Hopefully this answers your question. If not, please ask in more details.
Okay, another question. What tools do you use for classification? Libraries in R or Python, and which ones?
There, so Faldiska is in Python using pandas. Most production systems I know are in Java or Scala. So it depends. There are no, I don't know of any Python libraries that do it out of the box, but there might be some. Okay, I see a question on data observability. Tools be used for data classification. I don't think, I think it's the other way actually. Data classification really helps with data observability, because if you can go and find all the instances, for example, of quarterly sales or whatever your favorite observability point is, now you actually can build a baseline of what it should look like and automatically find discrepancies in other places. In fact, that's what Faldiska can do, is it can say, you know what, this data set has 99% correct date of birth, but here's all the instances where it doesn't match. And you don't have to write rules, right? It just does it automatically. If you say, here's what good data looks like, it can automatically compare it and say, well, if that's good data, then you have these records have bad data for this field. Using data lineage for classification, how does that work when a field is aggregated? For example, if the source has account ID and customer name, and target has an account ID and number of customer names associated with the account ID. So aggregation, okay, so if you have field level lineage, it actually interprets what's being done and can say that this is a count of customer names, right? If you don't have field level lineage and you want to detect it, it's difficult. I know there are some techniques, but they haven't been productized. But what you can do is you can say, look, if there is customer name in this data set, just assume there is customer name in aggregate data set. And therefore, we're going to protect it like a customer name until somebody tells us otherwise. I mean, the nice thing about privacy is, there is real implication, people complain. It's like many years ago when I was working on security, ATM cards, right? The reason there is a limit on ATM cards is because, there are some discrepancies and problems sometimes, and they don't do two-phase commit across the whole world. And so sometimes things break, but people always complain. People always look at the account, go, oh, no, that's wrong. And then the banks fix it. And it's much cheaper than trying to be perfect. I think the same thing applies here, right? If you are overly restrictive, people will complain. People will look and say, no, this is wrong, and then fix it. So sometimes it's okay to be a little more restrictive than less restrictive. Source libraries to match recognizable fields. don't know if there is a collection of regular expressions or libraries. I would guess there is, but I haven't seen or used it because we always, I mean, regular expression, there are tons of regular expression libraries, so you just define your own regexes. That's not a big deal. Let's see. What kind of confidence levels can reach for determining classification of fields and removing access from these? How much of this is manual checking? So I mean, that's the precision recall problem, right? Recall says, have you found all the instances, and can you trust that you found all the instances? And precision says, did you mislabel anything? And I think around 90% is where, you know, doing human curation doesn't really help very much. And you know, for a lot of labels, special recognizable fields, people are in high 90s. It's kind of easy to find emails, for example. For other things like codes and dates of birth and so on, yeah, there's usually false positives and depends. So usually you have thresholds and knobs, right? Like how confident are you? So you might find dates of birth, right? You can say, okay, anything that's from 100 years ago to now should be a reasonable date of birth. And often people look at quintiles or distributions and say, well, that's more likely, less likely to be date of birth. And pragmatic approaches, you know, especially with trainable classifiers, you calculate confidence, right? And below a certain level of confidence, you just ignore it. You say, ah, you know what, unlikely. Above a certain level, you don't bother people. You say, this is such high confidence, it's most likely to be correct. And then somewhere in the middle is where you usually reach out to dataset owners and ask them, hey, can you confirm that this is a date of birth? So usually it's a multi-step or multi-threshold exercise, and you determine based on reaching out. So a good heuristic is you reach out to 10 people, and based on that, you see if you improve your precision recall, then reach out to 10 more. And once you get to the very high levels, then you stop. Or if you can never reach those levels, then you rethink the classifier